Hi girls, here you are again. Here we go, marching through the functional groups once more. So just another two for you here that I just want you to be aware of and to know the names of and to be able to draw. Okay, so this whole section is really all about vocabulary and chemistry vocabulary and organic chemistry vocabulary. And really this year we're just learning the vocabulary and next year we look at the reactions a bit more when we're obviously, hopefully, in the lab all together. Okay. When we started looking at alcohols, we started by looking at carbon dioxide because that's something you're familiar with already. I think what's possibly important when you think of carbon dioxide is just to think of the bond between carbon and oxygen, and we looked then at alcohols from that. But there's another way that carbon and oxygen could be bonded, and I want to show you this here. And again, I've just drawn the dot and cross diagram here to show you how the electrons move. This, in some ways, this makes it more complicated. In other ways, it explains a bit better. So I'm just showing it to you anyway, just so you can see the difference, right? So carbon here, this time is double bonded to an oxygen. Can you see that? Two pairs of electrons there, okay? So we would draw that like this to make it a bit simpler, okay? And then there's a single bond to a hydrogen, like that. That's what this is, okay? And then this is just a normal methyl group, another CH3, like this, okay? So what I've drawn here is a way that carbon can bond to oxygen, okay? But it obviously isn't an alcohol, sure it's not, because an alcohol would have OH, it would have the H connected to the oxygen there, and there would only be a single bond between carbon and oxygen. So clearly what I've done here is a different functional group, you can see that. There's a C double bond O, and then there's a H coming off that carbon too. Okay, so that whole thing, this whole bit here that I'm drawing a big blue circle around, okay, is a new functional group and it's called an aldehyde. Okay, so forget about that bit for a minute. This is called an aldehyde here, right? That's what makes an aldehyde. It's just a type of functional group that you need to be aware of. I've made a model of it here. You can see it beside it. There it is, right? Sort of beside my fruit bowl there. Can you see that? So you've got two carbons. You've got the double bond oxygen at the top, and then you've got that little, this guy here I'm pointing to with my pen is the hydrogen. So that's the functional group. So this bit here that you can now see in front of the camera is the functional group, CHO. All right, is how it's written. So normally we write this like this, CH3, CHO is how we'd write that formula so that we don't confuse it with alcohols, which would be OH. Okay, so this is ethanol there like that. That's what that is. That's the second member of the series. Obviously, methanol would just have a hydrogen there, okay? So you've got ethanol, and then you've got propanol, just by adding another carbon to the chain there like that. So we've got methanol, ethanol, propanol, butanol, pentanol, etc. So again, the ending is anal, and the start of the word is exactly the same as all the other functional groups we've learned so far. Meth, eth, prop, bute, pent, hex, like that, okay? So methanol, ethanol, propanol, and they have this functional group here, CHO, okay? Very important that it's written like that, CHO, so that you don't confuse it with alcohols, which would be COH, if that makes sense, okay? Now, let's imagine for a second, I'm going to try and do this with my model if we can, right? So we said that we have this hydrogen here. Let's imagine we remove that hydrogen and we replace it with a methyl group like this, okay? So I'm trying to stick it on there. There it is. Right, it's on there now. Okay, so you see now the difference. So that what was a hydrogen is now gone and it's been replaced with a whole methyl group, CH3. So it's a similar functional group, but it's different. Okay, so if we were to look at what it looks like, it no longer, I've replaced this hydrogen here with a CH3 group like that. And it turns out that this is a completely different functional group. Okay, it's similar, as you can see, but it's different. That hydrogen, this one here, is now gone. Okay? So what you've got is you've got a C double bond O with a methyl group on either side. All right, so it's got a long chain like that with three carbons and a methyl group on either side. And this is called a ketone. Okay, ketones are different to aldehydes, different functional group. They react differently, as we'll see next year. They're less reactive. We don't need to worry about how. It's just this bond is much easier to break than either of these bonds, which don't really break. And again, this ends in -one. So the first ketone, there is no ketone with one carbon or two carbons because you must have a carbon either side of this C double bond O. This C double bond O here is called a carbonyl group. Okay, I'll write that down here for you, just so you can see it. It's a word you'll come across in your slides anyway. but just so you can see what it looks like. This bit here is called a carbonyl group, and if it's got a carbon either side of that, so it must have 3 carbons minimum, it's a ketone, okay? Now it could have 1 carbon either side, or it could have 10, but what's important is that you've got what's called an alkyl chain, okay? So a chain made up of alkanes either side. All right, so you can't have a hydrogen here, otherwise it would be an aldehyde. So propanone is the first member of the ketone family, and the next one, surprisingly, is butanone. Okay, 1, 2, 3, 4 carbons going like that, and that can go on, pentanone, hexanone, etc. Right, but you can see here what the story is. We've got the carbonyl group, we've got a carbon on that side of it, got a carbon on that side of it, and then we can make that chain longer or we can make that chain longer depending, doesn't really matter. But this is butanone. Realistically, you won't be asked any more than propanone or butanone. They're the only 2 members of this homologous series or this family that you need to know. Okay, so 2 functional groups here that are important: aldehydes, ketones. Make sure you can draw them, make sure you know what they look like, and you can recognize them. That's all we need to know for now. Okay, hope that helps. Bye-bye.